You know, every single app on your phone, every website you visit, every game you play, they all rely on this one single core concept: variables. They're basically the memory of a program. And in the next few minutes, we are going to break down exactly how they work. So let's dive right in.
All right, let's kick things off with a simple question. How does a computer, remember stuff? I mean, really, if you tell it to use the number 10, how does it actually hold on to that value so it can use it again later?
Hmm.
Well, the simplest approach is to not make it remember at all. We can just give it a direct command, right? Something like print 10. This just tells the computer, hey, display this value on the screen right now.
And of course, the computer does exactly what we tell it to. It just spits out the number 10. Super simple, totally direct, but also really rigid, right? So, okay, that leads to a much bigger question. What if we want to use that number 10 again? Later. Or maybe we want to add something to it. We need some way to store it, to give it a name so we can just grab it easily whenever we need it. And this is the solution. This is where the magic happens. Instead of just using the number 10 by itself, we put it inside a little labeled container. So here, we're creating a box, we're calling it A, and we're using that equal sign to assign the value 10 to it. Just like that, the number is stored and it has a name we can use. And that little labeled box, it has an official name. It's a variable. It's just a named container for a piece of information that, and this is the really important part, can be changed or, varied later on. Hence the name. Okay, so now we've got our number 10 stored inside that container we called A. So what do you think happens when we tell the computer to print A? Any guesses?
Yep, you got it. It prints 10. The computer sees the name A, it looks inside that box we created, it finds the number 10, and it displays that value. See? It's not treating A like a letter anymore. It's treating it as a reference, a pointer to the data it holds.
Okay, and this is where things start to get really, really useful. We can create as many variables as we want, right? We can have A holding 10 and B holding 20. And then, check this out, we can do math with them just by using their names. And boom, the computer gives us 30. It just goes, grabs the value from A, grabs the value from B, adds them up, and shows us the result. That is the power of variables in action. Okay, hold on. This next part, this is where programming starts to look really different from math class. So if you've ever taken algebra, this line of code is going to look like it breaks all the rules. A equals A plus 1. What? How can something possibly be equal to itself plus 1? This right here, this is the absolute key. In math, right, the equal sign is like a balance scale. Both sides have to be equal. So A equals A plus 1? Impossible. But in programming, that equals sign is not about balance. Think of it more like an arrow. It's a command. It's saying, hey, computer, first figure out whatever is on the right side. Then take that result and assign it or store it in the variable on the left. It is an action, not a statement of fact.
So let's actually follow the computer's logic here, step by step. First, we say A equals 10. Okay, the box A now holds the number 10. Then we print A, and we see 10. Easy enough. Now for that weird command, A equals A plus 1. The computer looks at the right side first. It says, what's the current value of A? Well, it's 10. Okay, add 1 to that. That gives us 11. Then the assignment command kicks in and tells it to put that new result, 11, back into the A box, replacing the old value. So what does that final print A give us?
And there you have it, 10 and then 11. The value inside our variable A has actually been updated. And this process, this idea of updating a value, it is one of the most fundamental, most important things in all of programming. You can really see the process in action here. We start with 10. The first time we run A equals A plus 1, the value becomes 11. Simple. But the second time we run that exact same line of code, the computer takes the new value, which is now 11, adds 1 to it, and the variable becomes 12. And you could do it again and get 13, and so on. The variable is truly living up to its name. It's always varying.
All right, so this is a pretty cool concept, but what's the actual point? I mean, why would you ever need to do this? Let's look at a really practical example, one where a program actually needs to interact with a real person. Let's see how this whole idea makes interactive programs possible. So imagine a program that prints a message. Enter a number. Now, this next line of code does something brand new. It just pauses. It waits for you, the user, to type something. And whatever number you enter, it gets stored in a brand new variable, which we'll call n. So now, the program can use that variable n, which is holding whatever number you just typed in. It can print the number itself, then it can print that number +1, then +2, and on and on. The really cool thing is, the code itself has no idea what the number is. It just knows its job is to use whatever it finds inside of n. And here's what that looks like in practice. If you, the user, enter the number 100, the program prints out 100, 101, 102, and 103. But if you had entered, say, 5, it would have printed 5, 6, 7, and 8. The code itself never changes, but the output is totally dynamic, all because the variable's value came from you. That is what makes a program interactive. Okay, so let's do a super quick recap. What have we learned? 1. Variables are just named containers for data. 2. The equal sign in code is a command to assign something. It's not about math-style equality. 3. That funky-looking a equals a plus 1 is a super powerful way to update a variable's value. And 4. All of this together is what lets our programs be flexible and interactive. And just like that, you now understand the fundamental concept that lets software remember things, adapt to new information, and interact with us. Seriously, every time you see a score update in a game, or a like count go up on social media, or your shopping cart total changes online, you are literally seeing variables at work. This is the bedrock, the foundation of all programming. So the only question left is, what are you going to build with it?